May 1951. The dawn light bleeds across the Pacific as the USS Coral Sea cuts through gentle waves, her deck alive with motion. Dozens of deckhands move like a single organism, fuel hoses uncoiled, bombs loaded, wings unfolded. Above the hum of engines, one voice dominates. Commander Elias Morton, 38, the ship's air boss. His world is measured in seconds, wind speed, and the distance between survival and catastrophe. 30 aircraft, Hellcats, Panthers, and Sky Raiders roar down the 872-foot flight deck and leap into the air, vanishing toward the gray horizon. A strike mission over Korea. They'll be gone for 2 hours. Morton watches them disappear, already calculating what comes next. In 2 hours, those same pilots will come home, low on fuel, some shot up, some barely conscious. And that's when the clock starts ticking, because the Coral Sea's flight deck is a bottleneck of steel, 872 feet long, 90 feet wide, one way in, one way out. No second chances. Each landing takes 90 seconds. Hook the wire, throttle down, taxi forward, fold wings, park. 30 aircraft times 90 seconds equals 45 minutes. Morton does the math again, hoping it changes. It doesn't. The last planes in the pattern will be landing on fumes. He's seen what happens when it goes wrong. One missed wire, one hard landing, one explosion, and the whole operation freezes. Smoke, fire, wreckage shoved overboard while the remaining pilots circle overhead, fuel gauges dipping into the red. Every second becomes a funeral countdown. Morton leans against the rail, looking down the straight, narrow beck. It's beautiful in its simplicity and deadly in its limits. He knows what the admirals won't admit. Every carrier in the world is built like a trap. Once all aircraft are back aboard, the deck becomes a parking lot of bombs and fuel. You can't launch again until you spend an hour rearranging everything by hand. A carrier that can't launch or recover when needed isn't a weapon, it's a target. Morton mutters under his breath, "One crash and we lose them all." He's not exaggerating. The Navy calls it the deck cycle, the rhythm of launch, recovery, respot, and relaunch. But to Morton, it's not rhythm, it's suffocation. Every minute lost means another pilot lost to the sea. Every inefficiency is a coffin in waiting. He lights a cigarette, the wind stealing most of the smoke before it reaches his lips. He's seen this cycle play out for years, from the war in the Pacific to Korea now. The problem isn't courage or training or weather. It's geometry, the straight deck, the sacred, untouchable layout of every carrier since the 1920s. But soon, someone, maybe Morton himself, will dare to question it, because survival, he's beginning to realize, might not come from bravery or luck. It might come from an angle. The sea was calm, but the fleet was paralyzed. The moment Elias Morton's pilots returned from their mission, the USS Coral Sea turned from a predator into a parking lot of steel and smoke. Every aircraft that landed became part of a growing puzzle, and every puzzle piece carried a bomb, a tank of fuel, and a heartbeat waiting for orders. Morton stood at the edge of the island tower, binoculars pressed tight. "We can't launch until we clear the deck," he muttered. It wasn't fear, it was fury. Hours ago, they'd pummeled a North Korean airstrip. Now, their own deck was the real enemy. The problem wasn't new. In World War II, both Japanese and American carriers had learned the same painful lesson. The straight flight deck was a death trap. Once planes landed, the entire top surface became jammed. Each bomber or fighter had to be refueled, rearmed, and repositioned manually. Until that was done, no new aircraft could take off. In naval terms, this choke point had a name: the deck cycle, the period between landing the last plane and launching the first one. Admiral Mark Mitzscher once called it the heartbeat of a carrier, and lately that heartbeat was slowing down. Morton knew the math too well. Each plane needed 90 seconds to land, 15 minutes to refuel, another 10 to rearm. Multiply that by 30 aircraft, and you got a cycle time of nearly 2 hours.
2 hours where the fleet was blind, motionless, and ripe for attack. He remembered the stories from Midway. Japanese carriers caught mid-cycle, decks full of aircraft with bombs exposed, wiped out in a matter of minutes. History, it seemed, was repeating itself. Below the tower, the flight crew raced like ants across the scorching deck. A single crash could block the entire runway. Morton had seen it before. One gear collapse, one explosion, and the chain reaction would doom them all. That night, in the wardroom, Morton's engineers spread blueprints across the table. "We could try dual rotations," one suggested. One ship launches while another recovers. But the math didn't work. It took 3 carriers to sustain what one should have done alone. Resources stretched, coordination failed, and human fatigue piled up. Morton slammed his hand on the table. "We're fighting a modern war with ancient geometry." And he was right. The ocean had evolved, the weapons had evolved, but the carriers had not. Their design was built for a different era, an era of straight lines, slower planes, and short missions. Jet engines and high-speed sorties had changed everything, but the deck stayed stubbornly the same. For now, all Elias Morton could do was watch the deck crew gamble with time. He knew the solution had to exist, somewhere between physics and desperation, but no one had dared to redraw the sacred geometry of the carrier. Not yet.
The war had ended, but the lessons of chaos still echoed through the steel corridors of the Navy's carriers. By 1946, as the world shifted from global war to Cold War, engineers and officers alike began to whisper about the same impossible question: how do you make a straight deck bend? Elias Morton, now serving as a test operations advisor, spent his nights staring at diagrams, top-down views of carrier decks that all looked identical. The same fatal flaw haunted them all. The straight deck, once a symbol of order, had become a symbol of limitation. The faster planes got, the worse the problem became. By 1948, the Navy's jet aircraft were landing at speeds 40% faster than World War II prop planes. One mistake meant a firewall. "Every landing is a coin flip," Morton said during a safety board meeting, "and one day we're going to run out of luck." The British, recovering from their own wartime losses, quietly began searching for answers. Captain Matthew Slattery of the HMS Illustrious noticed something unusual. His pilots often drifted slightly to the side during landings, unconsciously correcting for crosswind. What if, he wondered, that drift wasn't a flaw, but a feature? In 1943, he ordered his crew to paint a thin white line that angled 5 degrees off the center axis of the deck. Pilots began landing along the line instead of straight ahead. To everyone's shock, the side-angled landings worked. Fewer crashes, smoother recoveries, and no blocked deck when a plane bolted and went around again. It was crude, but promising. Enter Dennis Campbell, a Royal Navy physicist. He refined the idea: make the landing area itself angled, 5 degrees at first, separating the takeoff and landing zones entirely. No more waiting for a clear deck, no more deadly geometry. The HMS Triumph tested it in 1944, with legendary test pilot Eric Brown at the controls. The results? Controlled, safe landings. A revolution hidden in plain sight. But the war ended, and the idea faded into the archives, shelved as a British curiosity. The Americans, focused on jet development and nuclear propulsion, never noticed the quiet innovation buried in the files. Until one rainy afternoon in 1951. Morton, now stationed at Norfolk Naval Base, was reviewing post-war British reports. A small note caught his eye: a 5-degree angled deck trial, successful but unadopted. He froze. The simplicity stunned him. "It's not about new engines," he murmured. "It's about space, about flow." That night, he drew it himself, an 8-degree angle on tracing paper. Separate the launch path from the landing path. 2 lanes, continuous motion, the difference between chaos and control. But the Navy was skeptical. "We've done it this way for 30 years, one admiral told him. "You don't change the geometry of the ocean." Morton didn't argue. He simply smiled and said, "Then maybe it's time the ocean changes shape." He knew that to prove it, he'd have to test it, not in theory, but in paint, and soon the first experiment would begin, one that would redefine every carrier ever built. Act 4.
Climax: the American reinvention. The storm broke in 1951. Commander Walter Boone, a sharp-minded test pilot and naval engineer, came across Morton's sketches during a systems evaluation meeting at the Naval Air Test Center at Patuxent River. The design was unconventional, an 8-degree angle off the ship's centerline, but it answered every problem Boone had nearly died from himself. That same week, Boone and Morton proposed the unthinkable, a test aboard the USS Midway, using nothing but paint. No construction, no steelwork, no budget approval, just a white line drawn across the deck at a precise 8-degree angle. It was bold, reckless, and exactly the kind of risk the Navy needed. The first landing came at dawn. The pilot lined up with the angled path, missed the arrestor wire, and throttled up, expecting disaster. But instead of slamming into parked planes, he bolted safely off the deck, cleared for another attempt. The entire tower went silent. Then cheering erupted across the ship. It worked. Morton watched from the island bridge, heart pounding. "Gentlemen," he said quietly, "we've just changed the ocean." Over the next 2 weeks, test pilots executed 12 landings and 12 launches in just 18 minutes, a feat no carrier in history had ever achieved. For the first time, aircraft could land and take off simultaneously without rearranging the deck. The bottleneck was gone. The deck cycle, the Navy's old heartbeat, was reborn. But now came the true challenge: making the paint permanent. Between 1952 and 1955, the Navy began the most ambitious carrier redesign in history. Engineers reconfigured entire flight decks, moving the island superstructure aft, installing upgraded arresting gear, and integrating steam catapults capable of launching 60,000-pound jets. The new mirror landing system, using gyroscopic guidance and reflected light, allowed pilots to align perfectly with the angled runway even in rough seas. The USS Antietam became the first fully operational angled deck carrier. In its first exercises, it outperformed every straight-deck ship in the fleet, 68 sorties in 12 hours, compared to only 39 from its nearest rival, the USS Kearsarge. Deck availability surged from 42% to 79%. Pilot survival skyrocketed. Maintenance time plummeted. When the Korean War flared again, the difference was undeniable. The angled deck carriers could fight continuously, launching, recovering, refueling, and relaunching without pause. Boone called it the perpetual strike machine. Morton stood on the Antietam's deck during the final trial, the horizon split by gold light. 85% more striking power, he whispered, more to himself than anyone else. All from an angle. When the Navy Board convened later that year, the vote was unanimous. Every carrier, new or old, would be converted. The world's greatest fleet had just rewritten the rules of war. And for Morton, it was more than victory. It was proof that innovation didn't always roar. Sometimes it just leaned 8 degrees to the left.
By 1954, the angled deck was no longer an experiment. It was doctrine. Shipyards from Newport News to Puget Sound buzzed with welders, engineers, and draftsmen redrawing history in steel. The Navy's newest class of ships, the Forrestal-class supercarriers, were designed from the keel up to embody the angled deck principle. No more painted lines. This was architecture. The USS Forrestal's deck stretched over 1,000 feet, carrying 4 steam catapults that could launch and recover aircraft simultaneously. From above, the ship resembled a giant arrowhead, sleek, asymmetric, and alive. When it sailed in 1955, it wasn't just a carrier. It was a floating city of perpetual motion. Elias Morton, now retired but invited to the launch ceremony, stood among the admirals and engineers as the first jet took off from the portside catapult while another touched down on the angled deck. 2 operations, 1 heartbeat. His vision had become law. In a 1960 NATO readiness test, the Forrestal achieved 147 sorties in just 24 hours, nearly triple what a straight-deck carrier could manage. No other Navy could match it. America's carriers had become machines of endurance, capable of delivering continuous air power, day or night, in any ocean on Earth. Across the Atlantic, Soviet Admiral Sergei Gorshkov studied the results with quiet alarm.
A ship that never stops fighting, he wrote in a classified memo. There is no countermeasure for that. The angled deck had done more than solve a logistical problem. It had shifted the balance of naval power for generations. From the Korean coast to the Mediterranean, the supercarriers became floating empires. They projected power not through numbers, but through rhythm, a seamless loop of launch and recovery that made them eternal. Pilots began to call them rolling thunder platforms. Engineers, with more restraint, simply called them perfect. Morton watched film reels of these new giants in action. Jets slicing through fog, flight crews guiding metal monsters with batons of light. The angled deck was everywhere now, in every navy that could afford it, on every ocean that could hold it. What began as a painted idea had become the cornerstone of modern warfare. He once said the old carriers were floating bombs. Now they were floating symphonies. And he couldn't help but smile at the transformation. In the distance, the Forrestal's deck lights shimmered across the dark sea. The ship was still working, launching, landing, refueling, relaunching, a rhythm unbroken. The old deck cycle was gone, replaced by something infinite. Morton whispered to himself, it was never about power, it was about flow. The year was 2017. The USS Gerald R. Ford, the most advanced carrier ever built, cut through the Atlantic with a quiet, deliberate power. Electromagnetic catapults replaced steam. Advanced arresting gear replaced cables. But one thing remained untouched: the 8-degree angled deck. The same geometry Commander Elias Morton and Walter Boone had tested with a line of paint more than 60 years ago. Technology had evolved beyond imagination. The jets were faster, the computers smarter, the radars sharper, yet the angles stayed. Not because it was tradition, but because it was perfect. Every landing, every launch, every recovery still relied on that same elegant deviation from the straight line, the subtle genius that had saved countless lives and redefined naval warfare. In a museum near Norfolk, Virginia, a faded blueprint hung on the wall. Morton's original sketch, pencil marks smudged, notes scribbled in the margins. "Flow over force," he had written, beside the angled outline. School children walked past it without realizing they were looking at one of the most important drawings in military history. At sea, the Gerald R. Ford's deck crew continued the rhythm Morton had dreamed of. Jets landing and launching in seamless harmony. A young pilot, barely 23, once asked his commander, "Why don't we just make it straight? It'll look cleaner." The commander smiled, because perfection doesn't always look straight. The angle had become more than a design. It was a philosophy, a lesson in humility and brilliance. Great innovation, Morton had proven, wasn't about adding complexity. It was about removing chaos. Standing in that museum decades earlier, Morton had once reflected, "We didn't invent the angled deck to make war easier. We made it to make survival possible." And in a way, that's what every great innovation does. It tilts the world just enough to make the impossible work. From the roaring decks of World War II to the silent precision of the Ford-class carriers, one truth remained constant. Sometimes, progress isn't about revolution. It's about a gentle 8-degree turn that changes everything. As the sun dipped below the horizon, painting the ocean in gold, the flight deck glowed like a blade of light across the sea. Morton's legacy endured, not in statues or speeches, but in geometry, in the perfect angle that turned chaos into order.